Welcome to Chem 2045, Hess's Law Lab, or enthalpy of reaction law. In this law, we're going to use 1 molarity hydrochloric acid, 1 molarity sodium hydroxide, magnesium, and magnesium oxide, as well as a calorimeter. You'll notice the lab report that's attached in the description of this video. You'll pay special attention to the equation on page 2, because the first thing we'll do is solve for our calorimeter constant, our Cc. You'll need to rearrange the equation there. After that, you'll be able to know everything except for your enthalpy of reaction for the 2 consecutive reactions after our first one. You'll also notice the data tables at the back. You won't need to use the data tables. Instead, you can get data from the graphs that we are showing in the video here. So the first thing that we're doing is measuring 50 milliliters of 1 molarity hydrochloric acid, and we are taking the temperature. It's 20.9 degrees Celsius. Then we're going to take our 1 molarity sodium hydroxide, again 50 milliliters, and we are going to get the temperature of that as well. And we get 21.1 degrees Celsius. We're measuring it again inside the calorimeter, just in case the calorimeter would have thrown off the temperature at all. And you'll need those again to find the average starting temperature shown in the lab report. We're going to start recording our data before we start the reaction. So we'll add our 2 products together. And the reaction is, of course, immediate. It'll start bubbling and releasing heat energy. So we'll seal that up as quick as possible. And now let's take a look here at our vernier instrument. And we see that the temperature increase is pretty immediate. And we're going to let this run for several minutes. We'll be looking for a valley to know that the reaction is completed. Every now and again we'll need to give it a little swirl, just because our products start to settle. We want to make sure that this reaction completes fully. And just in case there was any confusion about my initial measurements in this video, we measured 50 milliliters and then we added the thermometers, so there was some displacement. It may have looked like it was slightly more than 50 milliliters of each of those reactants. So again, we are seeing a slow but steady change in temperature here. So we'll continue to monitor this. And eventually here we get some data points at the end of our video, or at the end of our reaction rather. And we get a final temperature of about 31.9 degrees Celsius. Each color of graph there denotes 3 minutes. And so you can see where we have a final temperature here after 12 minutes. Now we're up to about 32 degrees Celsius, comes back down to 31.9. Next reaction, we'll measure our magnesium, 0.284 grams of magnesium. We'll again take the temperature of our hydrochloric acid. We're at 21.1 degrees Celsius. Recording it at 22.2 degrees Celsius officially. We'll begin to record our data before we add the magnesium. And now we've got our reaction underway. We'll seal our calorimeter. And again, this time you know your Cc in that equation on page 2. And so now you are calculating for enthalpy of reaction. And now you're dealing with a solid here, and your liquid, again, that's 1 molarity HCl, 50 milliliters. So it's going to take a little bit longer. And it will require a little bit more swirling as well as some of that reaction takes place. We'll need to continuously expose that magnesium to fresh hydrochloric acid. And again, we have a slow and steady incline here, as you can see. Now we're starting to level off just a little bit. Give it another swirl just in case. This time we're set up for 780 seconds. And so you can see the time at this point. We're up to 680 seconds and we're at 27.5 degrees Celsius. It's really starting to level off now. And so that's what we're going to use as our final temperature. Lastly, we're going to use our 50 milliliters of HCl, 21.1 degrees Celsius. And then we have 0.531 grams of magnesium oxide. Again, we're already running our data. We'll fill up our calorimeter. And you can see this one's going to be in need of some additional swirling and mixing there to get our reaction going. Our initial temperature we saw was 22.1 degrees Celsius. And so the reaction is running. This one takes a bit as well. 13 minutes later, we finish with a final temperature of 25.4 degrees Celsius. And so now you have all the data that you need, and thanks for watching.